In the dim light of an underwater meadow, something hovers between shadow and shimmer. Its body is neither fish nor coral, its shape shifting in soft waves as if the water itself is thinking. Patterns ripple across its skin, pulses of ochre, white, and shadowed ink, flowing like sentences we can't yet read. A small crab wanders too close, claws twitching. The creature's pupils, bent into strange W-shaped slits, narrow almost imperceptibly. It waits, not frozen, but calculating. In a flash, the crab could be seized, yet the predator holds its ground, ignoring the temptation. Minutes pass. Then, when the tide of opportunity turns in its favor, it strikes, decisive, clean, final. In a sealed laboratory tank, this same restraint plays out in a different form. Researchers place 2 meals before it. One, immediate but meager. The other, richer but delayed. The choice is clear, at least it should be. For a creature without a backbone, without the neural hardware we associate with patience, waiting is a skill not often found. And yet, it waits. It passes a test once thought the province of primates and human children, a marshmallow test of the sea. For decades, cephalopods have been the ocean's cipher, octopuses that solve puzzles, squids that orchestrate light, shows in the dark, and here, their lesser-known cousin with an equally alien mind. Cuttlefish intelligence has long been underestimated, partly because their lives unfold in silence and solitude. Unlike dolphins or chimpanzees, they do not live in tight-knit social groups where communication drives cognition. They drift alone through seagrass beds and sandy flats, masters of disguise, their survival depending on the art of being unseen. To evade predators, they command skin packed with millions of chromatophores, pigment cells that can expand or contract in milliseconds, overlaying structural iridophores and leucophores to bend and scatter light. Camouflage is their shield, but it is also a performance. They must choose, in an instant, whether to vanish into the background or explode in warning color. Every display is a decision, every disguise a hypothesis about what the predator sees. Delayed gratification, the ability to forego an immediate reward for a better one later, seems an odd fit for an animal with a lifespan of barely 2 years. Why invest in patience when the clock runs so fast? Yet in controlled experiments, cuttlefish repeatedly show restraint, refusing a morsel to secure something more valuable minutes later. This self-control is linked not to social politics, as in apes, but perhaps to the ruthless calculus of hunting. When stalking prey, a premature strike wastes precious energy. In their natural habitat, a mistimed attack could mean revealing themselves to predators lurking nearby. Waiting, then, is not a moral virtue. It is a survival tactic, sharpened by millions of years of evolution. Here lies the twist. In the realm of invertebrates, this level of impulse control is nearly uncharted. Passing the marshmallow test requires more than instinct. It demands working memory, the ability to hold a goal in mind while ignoring distractions. It hints at episodic-like memory, recalling what happened, where and when, to plan future actions. For vertebrates, these skills evolved alongside complex brains, often in social contexts. But cuttlefish live largely alone, meeting only to mate. So why develop a mind capable of planning ahead? What ecological pressures carved such cognitive architecture into an animal whose body is soft enough to fit through a bottle's neck? Some scientists suspect the answer lies in their hunting strategy. A cuttlefish must often wait for prey to venture into optimal striking range. Too soon, and the target escapes. Too late, and the current shifts, the light changes, the moment is gone. Patience here is not passive. It is active calculation, adjusting camouflage, controlling breathing, watching the subtle drift of sand and shadow. Others point to predator avoidance as the true driver. In open water, revealing oneself for even a second could be fatal. A cuttlefish that can suppress the urge to lunge at every small opportunity might live long enough to seize the right one. The capacity to weigh immediate hunger against the risk of exposure could mean the difference between breeding and vanishing without a trace. A third possibility reaches deeper into their evolutionary lineage. Cephalopods share an ancient ancestry with shelled mollusks, creatures protected by armor, not wits. As shells diminished and vulnerability grew, the brain took on the role of shield. In this view, self-control is just one branch of a larger adaptive explosion in cephalopod cognition, a set of tools forged to manage life without a permanent defense. Among these tools, flexible camouflage, spatial mapping, and the ability to pause, to wait for the world to shift into the right configuration before acting. None of these theories fully answer the core mystery, because in the sterile confines of a lab, there are no predators, no shifting tides, no camouflage to maintain. Yet the cuttlefish still waits, as if carrying an ancient algorithm written in nerve and pigment, a program that whispers, "Not yet, not yet, now." In the wild, a cuttlefish's life may end in a sudden rush, a predator's strike, a failed hunt, the final exhaustion after spawning. But in those moments before, every choice is a balance between hunger and survival, impulse and strategy. Patience, it seems, is not bound to our definition of intelligence. It can exist in alien minds, wrapped in soft bodies, pulsing with colors that speak in a silent code. Somewhere, right now, beneath a wash of emerald seagrass, one waits. Not because it must, but because the ocean has taught it that the future, however brief, is worth holding in the mind. And so it hovers, unseen, until the moment comes. A moment that may be its last, yet also its proof that thought can flourish without a backbone.